make judgment if your analysis on your software is make sense or not. Okay, so let's see how we start doing analysis using any software. And one of them is SAP 2000 because it's most of the softwares are similar. So let's put SAP 2000 and I got version 25. This is the, I believe, the most or the latest version. And here I'm gonna use the trial version. As I told you, I have 20 days left. All right. So the first, when you open SAP 2000, you'll have a screen like this. It's a blank page. We didn't start anything. So what we are gonna do, we are gonna start with File, New Project. We need to make a new project to solve the stress. So it's called a new model. I'm gonna make a new model. If you have already models that you already did before, you can say File and open existing models. Okay, so when we open them, it asks you what units that you want to use in your project. So if I'm giving you the problem in kips inch, so I'm gonna make the units kips inch. If it's ton meter, so I'm gonna choose the unit ton meter so I can make it easy for me. So this is the first thing that I decide on the units, and this is very, very important. But somehow, if you choose different units and you want to change it in the project, you can hit the units, whatever units that you want, and when you want to change it, you can change it from here. Okay, so this is one thing. The second thing is the software gives you some choices to make it easy for you to do analysis of structures. If you want to start with a blank page, nothing in this page, you will start your model from scratch, or you want to draw some grids that can help you draw your problem and also give you some templates to start from. So you have a B, 2D trusses, 3D trusses, 3D frames, 2D frames, 3D frames, walls, slabs, also tanks. So you can start with one of these templates, but what I prefer is, if there's two ways that I do when I do analysis for a project. If my structure is very simple and I can do it on SAP 2000 very easily, I start with grids. But if my structure is complicated, like if I'm doing structure analysis for this structure, and I have the CAD drawing and I have everything, I import the structure from AutoCAD on a blank page. So I do it on AutoCAD and make the AutoCAD like on an extension is called DXF, and I export the DXF to SAP 2000. But since my truss is very, very simple, I'm gonna start with some grids that can help me draw my structure on this screen. So what I'm gonna do, I'm gonna say I'm gonna choose the unit ton meter, and I'm gonna say I want to grids only. So when you click on grids, the software is gonna ask you what is the spacing between grids that you want. And since I have here an AutoCAD, this is the geometry of my problem. I have a spacing in X direction 3 meters. So I need one grid each 3 meters so I can draw these members. So each 3 meter, I need a grid. And in the vertical direction, and this is Z. When we go up, this is D. This is X, Z, and the one inside the plane is Y. Okay. So since my structure is in X, Z direction, so I have a Z grid at this level, 4.4 meters. So I need 1, 2, 3, 4, 5 grids in X direction, and I need 2 grids at a spacing 4.4 in the Z direction. So let's get back to SAP 2000. Okay, so to ask here, what is the number of grids that you want in X direction? So I forgot. Do you guys remember? 1. I need 1 here. 2, 3, 4, 5. I need 5 grids in X direction. So I will say 5. And in Y direction, okay, so for this problem, how many grids in Y direction? 0 or 1? 1. Why? Because I have 1 here at Y. 0, that means that there is nothing. But you have 1 to start from, but we don't need 2. We only need 1. So we need 1 in Y direction. And Z direction, how many?
2. What is the spacing in X direction? It was 3. Y, it doesn't matter. Like you can keep it 6 because you only have 1. But if you have 2, 6 matter. Then Z, I have 2. And sorry, yeah, 4.4. Let me double check. In Z, I have 4.4. And the vertical grid line location at 0 and 0. So it asks you, where do you want your grids at? Start from 0 and 0, or I mean the origin, or start from somewhere else? I need 0 and 0, and then I will hit OK. So here it's gonna make your problem
how you draw the grid. So it shows you how's the grid. It divides the screen into 2. If you want to make it 1, if it's convenient for you to make it 1, you can escape 1. Like if you can hit this X. But I always, when I do structure analysis, I keep a 3D view in one screen and 2D view on the other screen. So this is the 3D and this is the 2D. And I make the 2D and depends on the problem. So my problem is an XZ, so I keep this XZ. My problem is XY, I keep this XY. This one is XY, but I need it to XZ. I can change it from here. You can switch the
views from up there. So if you look up there, you will find, if you want to make this 3D, it's gonna be 3D like this. If you want it XY, XZ, YZ. So I wanted XZ, so it's gonna be something like this, okay? So right now, what I did, I prepared the geometry to be drawn
by drawing grids that can help me draw my structure very fast. Okay, so the next step is for any structure analysis software, you need to define various the materials. You need to define the cross sections that you have. So if I'm designing this building and I know what is the different beams? So I have beam cross section that is 50 by 25 and one that is 1 meter by 40 centimeter. So you have to define all these cross sections, steel beams, concrete beams. And if you have only 2 materials in your project, one of them is concrete, one of them is a steel, you need to define these materials here. Sometimes in complicated projects, we use multiple or different materials of concrete, like we use concrete strengths for columns different from slabs. So you'll have to define 2 different materials, like the columns is gonna be high strength concrete or ultra high strength concrete, but the slab is gonna be normal concrete. So you need to define 2 materials. Same thing with the steel. Sometimes there's different steel material. So we need to define all this, and we can do this from where is that? Define. So you go to define
and define all this. So let's go to define and see what we have there. So if I click on define, the first thing that you will find is the materials. So I click on materials, and in materials, I will find that
I'll find SAP2000 already defined 2 materials for me. One of them is a steel, this one, and one of them is concrete with a strength of 4,000 pounds per square inch. So if you want to use, if these materials satisfy your needs and have everything that you need, you can use them. But if this material doesn't match the materials in your project, you will have to change them. You either take a copy and change it, or you change it itself. So what I'm gonna do here,
SAP2000 gives you the option if you want to add a new material from scratch and you define everything, and I don't want to do that. Or you can add a copy of this material and keep changing this copy as much as you want, or you modify this material itself. So what I'm going to do, I'm going to add a copy. So it's going to add all the parameters of this concrete, and you can change the name. So for example, you can call it concrete 30. And you put all, like ask you what is the material grade, you can change it whatever you want. The concrete weight, sometimes the concrete weight is very from 2.4 ton per meter cube to 2.5. So if your concrete weight is 2.5, you can change this from 2.4 to 2.5 and make sure that this unit is right. So if you change the unit from ton meter to kilonewton Newton centimeter, so everything is gonna change, okay? So sometimes some of you know the gamma of the concrete and the American units, and he doesn't know how it looks like in the SI units. So you change the units and you put it put it in the form in the unit that you know. Okay. So I know the gamma of the concrete, the weight per unit volume, in the SI units. So I'm gonna change this back to ton meter and put it 2.5. The second thing is the Young's modulus, and this is what we talked about last time. We said that Young's modulus in the ECI code is 4700 root FC dash, and this is a megapascal, and you can like transform the unit to be ton meters. So I will keep this as is, and the Poisson ratio of the concrete is 0.2. We cannot change that because this is constant. And FC, the specified concrete compressive strengths. If your project use different strengths, so you change this strength because there is ultra performance high concrete, ultra strength high concrete, and there is normal concrete. So based on the type of concrete, you can change this number. So once you are done with your material, you hit OK, you will find your new material is in the material list. Same thing with a steel. You go to the steel, modify, and you can change the name, so whatever name that you would like, or the grade, and then you will have the weight per unit volume. Same thing, the Young's modulus, the Poisson ratio, and also you will have, for the steel, you have the yield and you have the ultimate. So it has yield and ultimate. If you want to change these, you can change them. But let me tell you, most of these parameters, like the other properties of the steel material, like minimum and expected yield stress of the steel, they are used for design. If you are going to use the software to design sections, for design, we need a strength of material. Never in the structure analysis we have used F yield or FCU, like the compressive stress, because we don't do design. But we need the we need Young's modulus, we need inertia, we need gamma to calculate the weight and dead loads. So we need these parameters for structure analysis, and we need these parameters to do design. When we talk about strengths, so strengths is used for design. So at this level, I don't care about these numbers because I'm not doing design in this course. But if you are going to design a new project, you will have to make sure that these numbers are right. Okay, so once you define your new material, you will hold OK, and then you will find the new material is got in the list. And then I will say, OK. The second thing is I will have to define the cross section. So here, when you go to the second one on the list, it says section properties. And it asks you what kind of frame sections that you need. So here you can define frame sections. You can define tendons if you have like post tension or something. Cables, if you have a cable problem, you can use this. Area section, if we need to define a floor area or a shear wall. And there's some solid sections and other sections that you can define. But right now, I need, what should I use for the truss problem? Frame, tendon, cable, area, which one? What do you think? Right. Frame, right? Because this is a truss, so we'll use a frame. It's not tendon, it's not a cable. Okay. All right, so let's go to frame section and start the definition. So when I go to frame sections, I will find it empty. So I will have to start from scratch. I'm gonna say add new property. Import if you have something already pre-developed and you want to import it from the outside. But for this one, I'm gonna add a new property. So when you click add new property, the first thing it's gonna ask you, what is the section property type? What is the frame type? Is it steel, concrete, aluminum, whatever section that you have? So I think trusses, we can use a steel section, but you can also use concrete section if you want. So like, for example, you can say concrete. And when you hit concrete, it's going to open some example sections, rectangular, circular, tube. So if you click tube, if you click rectangle, it's going to ask you about the name of the section. So for example, I'm going to name it beam 70 centimeter multiplied by 30 centimeter. I usually name the section a unique name that can describe the parameter. So like if I have a project that have many beams, like 10 or 20 beams, and how can I distinguish them? I say beam one, and then I put the depths and widths so that every time I use the beam, I know that this is the cross section. And the second thing, it asks you about the depths. So if you put the name of the beam, like for example, 70 and 30, the section still didn't change to 70 and 30. You will have to change them because this is just a name, but you will have to input the depths and the widths here. So let me put here 0.7 and put here 0.3. The third thing is the material. You need to define the material because you have multiple materials. So you need to say that this section is 70 by 30 centimeter, and the material is, for example, concrete 30, the new material that we define. And there's something is called set modifiers. If you click on set modifiers, it asks you, do you want to make this section a little bit weaker than it's supposed to be? Like, do you want to make this section work with 70% efficiency or 50% efficiency, assuming some level of cracking? So you can set a modifier for the cross section, like the moment of inertia, the area, and say this is not 100%, this is 0.5 or 0.2. In earthquake, when we design cross section, we design crag cross section. So we usually adjust all these parameters, like we adjust the columns to as far as I remember, 0.7, the slabs is like 0.25 or something. So we adjust these inertia. And sometimes some problems, sometimes you are getting some beam problems that a cross-section area, like when we solve the structure analysis, is 2 EI and one is EI. So we can multiply the inertia by 2 for the same cross section. So it's gonna give you the same thing. Okay. All right. So I'm gonna keep them one because I don't have any like different inertia. And I'm gonna say, okay. So I divide the cross section. If you want to add a new property, you can add, and then you can exchange, for example, steel, and you can check an I-beam. And for the I-beam, it asks you for the information for every part of the I-beam, like the outside height, the top flange width, the top flange thickness, the width thickness, the bottom flange width, the bottom flange thickness. So it's asking you about this and the thickness, the height and the thickness. This one, so you can make this smaller than the lower one. So it asks you about everything. And here it asks you about the material, and then you'll get okay. So let's say this W1, and I'll say okay. So once you name it, you will find that the cross section is listed here. Then I will say okay. So for now, I defined the materials and the cross section. The second thing on the list to define is the load pattern. So I need to predefine what pattern of loads that I have for this problem. Sometimes you have only dead load, sometimes you have dead and live load, sometimes you have dead, live, wind, rain, seismic. You need to define all the load pattern. Just tell the software that this problem is gonna have this specific load pattern. So I go to load pattern, and by default, the software is gonna have the dead load. Okay, and for the dead load, most of the software, it calculates the dead load for you. Like if you draw a cross section and you give the software the gamma, it's gonna calculate the weight of the cross, the weight of the member. But if you put self weight modifier 0, is put the weight, is gonna put the weight to be 0. Okay, but if you keep it 1, it's gonna calculate the weight of all members and multiply it by 1. If you put it 0.5, if your beam is like 2-ton weight and you put 0.5, it's gonna multiply the 2-ton by 0.5 and make it 1. Make it 1, the half of the 2. So for this problem, the one that I have here, let's get back to the cat. Most of the structure analysis problem, I always give you loads, something like this, or I give you moment, or I give you the distributed load.
and I don't ask you to calculate on weight. Same thing with this process. I gave you the load at the joints, and I didn't ask you to calculate the on weight of the truss itself. Mostly, I calculated all the truss weight, and I make it concentrated at the joint. Like, for example, this truss, when I calculated the weight of this truss, it was 13.9, the whole weight of the truss. And I divided it onto 3 joints, and I put 4.2 here, 4.2 here, and 5.5 here. That's what we do when you get your profit. So for this truss, I'm gonna neglect the weight of the truss. And I'm only inserting the loads that I have, because I already gave you the dead load and I gave you the live load. I didn't have to calculate any dead load. Okay, so I'm gonna put on the software that I don't want to calculate dead load for me or any loads for me. So I'm gonna put the self weight to be 0. And once I write it here, it's not gonna change it here. So I have to hit modify load pattern. Once I modify, it's gonna modify the load pattern. The second thing, I'm gonna define live load, and I have to change the type to live. And I'm gonna make the modifier to be 0, because if you put self-weight modifier 1 in a live load, so what is gonna happen? The software is gonna calculate the dead load and put it in the live load. So I'm gonna put the self modifier, don't calculate self-weight of the structure, and put it in the live load case. So I'm gonna keep it 0. And then I'm gonna add new load pattern, and it's gonna be added here. But if you hit modify, it's gonna modify the already dead load. So you need to add another one. If I'm gonna, like if I have earthquake, I'm gonna write earthquake, change the type to earthquake, self-weight modifier 0, and I'm gonna add new load pattern. And you keep adding all the patterns that you have, all the load patterns that you have. But for our problem, this is a special case that we have the dead load self-weight modifier 0, because our problem doesn't include self-weight. But if we are doing our project, we don't want to calculate the dead load by ourselves. We need the software to do it for us. So for our project, we will keep this as a 1. So I ask the software, calculate the self-weight of the structure and put it in the dead load. Okay, so once I'm done, I will hit OK. So all the load patterns are there. So I didn't draw any structures yet. I'm just preparing my problem to be solved. I defined the material, I defined the cross section, I defined the load pattern. So the next thing is to draw the geometry. So let's see how we can draw the geometry. So to draw the geometries, there's different options that you can use. You can use the draw panel here, or you can use it from here. You will find all the options in the draw panel. Each option, you will find it here. So you can either use it from here or use it from here. And since we have the frame members, so we are gonna draw a frame, but there are many options to draw frames. There's an option that you can draw a frame by start and end point. Like you have to start here to here, okay? And there's an option, it's called quick draw frame. Quick draw frame is when you hit your cursor on a grid, it's gonna draw a frame. So let's try both. So for example, let's draw a frame, like something like this. When I hit draw frame, it's gonna ask you, what is this frame name? Like, because you have many cross sections. So the most important thing is to define the name. If you have like 5 cross sections, you will have to choose one of them here. If you draw them by default, it's gonna keep the default. It happens to be that our default is the Verus beam that we have, being 70 by 30. So I'm gonna keep it and draw our Verus beam. So when I come here on the grid, when I move the cursor to this point, can you see what happened? The snap catch me so that I can draw it. That's why I made a grid, because the grid helped me to draw the problem. So I made the first point, and then the second point, when I come here, I can click on it. So for this one, I used draw. Let's see what will happen if I used quick draw, this one. Quick draw, when I click on it, it will tell me that this is the cross section. So once you click on a grid, it's gonna draw a member. You see? Once I click on this one, it's gonna draw
but I have to do it one by one. So I have to click it one by one. For me, I found it easier. Like sometimes you think this is easy to do it, but I can draw one like something like this, and I start from this point and I go to the end point one at a time. And then you can keep continue, like you can make this and then this one. But for this one, let me check the CAD. Okay, so I can do it this way. So if I want to escape, you can make a right click. When you right click, you are still in the drawing without escaping the drawing. But if you hit escape, you'll have to start from scratch. Like you have to click one more time and then draw the member. But if you are drawing and you want to still be on drawing, you make a right click. Okay, then I will make the last one. Sure, yeah, I can do that. So let's get back to the load pattern. Okay, so for load patterns, we are defining, we didn't assign any loads from the start. We didn't draw the structure yet when we're doing this. We're just preparing the software to tell him we are going to use a specific load patterns, dead, live, seismic, wind, whatever loads that we have. Then I put them one by one, and I make the self weight. All of them is 0, except the dead loads. Depends on my problem. If you want the software to calculate the dead load for you, like you have a concrete members or steel members, you ask the software to calculate all the dead load of the structure. You can do that by putting the self-weight multiplier to 1. Where do you want to save this self-weight? Usually we put it in the dead load because the self-weight of the structure is a dead load. So when we put it 1, we keep it in the dead load pattern, not the live, not the wind, not the earthquake. Okay, so this is how it works. But in my problem, I didn't have any dead load. Like the dead load is, I mean, like I have a dead load, but it's already pre-calculated. I give it like in the exam that like I give it to you guys. For example, I give you this problem in the exam, this game problem. Why you didn't calculate dead loads of all this structure? Because I already give you some loads. I didn't ask you to calculate them. And that's most of the structure analysis problem. Like for this one, you can see that this is a steel beam. Why you didn't, when you were solving this structure, you didn't put a uniform load of the steel beam? Because I didn't ask you to do this. Okay, we neglected the beam load with respect to the loads that the beam is having. Okay, like for example, if your beam weight is 2 tons, but you have loads on your beam that is 100 tons. So this 2 tons is nothing with respect to the 100. Okay, so when our problem right now, we neglected the own weight of the structure with respect to the loads that we have. So we don't put a self weight. But when we solve a big project and a real project, like if I'm solving this truss in a real project, I will have to include a dead load.
No, I have a question about the coefficient live. You said that if you put it 1, it considers the dead load as a load.
Yeah, it will calculate the dead load of the structure and save it in the live load case. And we don't do that. Okay. All right. Let's get back here. All right. So right now I draw the structure. So what is the next thing? What do you expect? So I draw what is missing here. Two things, boundary conditions and loads. These 2 things. So let's put them. So the boundary conditions that I have roller on the left and hinge on the right. So you are gonna choose the joint that has a boundary condition. I'm gonna choose this one. And when you want to impose something on your structure, you always go for assign. So you will find the assign, and then I'm gonna assign something on a joint. So I click on joint, and then I'm gonna click on restraint. Because I want to make a restraint on this joint. I want to restrain some motion. So assign joint restraint. So here it gives you the shapes of the boundary condition. I know that there's a hinge here, so I click on the hinge. So it will tell you what translations that you can that the hinge is gonna restrain. So hinge in a 3D usually restrain all the motion in X, Y, and Z, and that's what we want to do here. Actually, you can restrict the translation in 1 and 3, and you can neglect 2 because we don't have Y direction. But having 2 is not gonna hurt. So if you click on this 3, it's not gonna hurt. Okay, so I'm gonna say okay. I'm gonna say apply. When I say apply, it's gonna assign the hinge without closing the problem. I mean, without closing the assign, so that you can choose another joint, and then you can assign a roller, and you can hit apply. Actually, in previous version of SAP 2000, like 10 years ago or 7 years ago, we didn't have this option that we do apply, and then we can choose something else and hit OK. In previous version, you say OK, and then you have to do another assign and open another window and do this one. So that's much better. So I have the boundary conditions, hinge and roller. Let's go to the second thing. The loads. Okay, let me check the problem. So I have these joints have the same, almost the same dead load. So I have 4.2 and 4.2. So I'm gonna click these two joints.
We were assigning the support point because it was mentioned here 1, 2, 3.
Yeah.
So 1 means X,
2 means Y, 3 means Z. Yeah. All right. So I choose the joints that has loads, and then I hit assign. So there's assign joint like properties, and there's assign joint loads. So there's two different types of assignment: assign properties and assign loads. So what we are going to do right now, we are going to put loads in these joints. So I'm going to say joint and joint forces, because I'm not assigning a displacement. Sometimes we can click on this joint and say that this support is going to have a displacement of 2 centimeters. So you assign displacement, but this is not what we are going to do right now. We are going to put loads of 4.2 ton at these joints. Assign joint load forces. Okay. So here it asks you what the load pattern of the load. So when I click on this, I will find all the load patterns that I define. If you define earthquake wind, you will find in the list wind. So right now I have dead. So I click on dead. What is the direction of this load? Negative Z, right? So what I'm going to do here, I'm going to go to Z, and I'm going to assign negative 4.2. So don't forget the negative. And then I'm going to say apply. You'll find the two loads here, and then I will get to this one. I have 5.5, negative 5.5, and then I will say apply. Then I will get back to this joint. What is special about this joint? Has live load, right? 5 ton. So what I'm going to do, I'm going to change this from dead to live, and I make sure that I remove negative 5.5. Why? Because if I put 5 ton, what is the direction of 5? Positive what? X. So I put 5 here. If you didn't remove the negative 5.5, it's going to add a negative 5.5 load, live load in the Z direction. Okay. So I make sure that I make this 0. Why I'm doing this? Because can you see here what I'm going to say is options. So for options, it asks you all the loads that you are going to have here. Do you want them to be added to any existing load, or replace existing load, or delete existing loads? So what I'm doing here, if you have whatever you messed up with the loads here, so I'm always on replacing existing loads, even if this is 0. So I keep
replacing, because if I'm replacing zero, it's like adding to existing. So being on replace existing load is the best way to assign loads. So right now I have 5, so what I'm gonna do, I'm gonna add okay. But if you, for example, you did a live load, okay, and put 5.5, and then you looked at the problem and you find another live load here. So you can do 2 things. You can redefine the loads, like put 5 and here -5 and say replace existing. So what will happen is gonna replace this one. But you can also add to existing by making this 0 and making this -5. Okay, you guys got that? So add to existing is gonna see what loads that you have. I'm gonna add them. Like if you have 5 and you add more 5, it's gonna be 10. Okay.
All right, so what I'm gonna do here, I'm gonna say 5 and I will say apply. Let's see what's gonna happen. Let me say okay. So when I said okay, it deletes all the other loads and only show the 5. So what happened to the other loads? Are they deleted? No, they are not. So what happened? SAP is designed only to show one load pattern, either live or dead. So once you put 5 in a live load pattern, it says here that the joint loads that I'm gonna showing is only live load. If you want to show different load pattern, you go to display and then show load assignment on joins. Show object. And then you will say dead, and then you will say okay. So you'll find the dead loads that you have. So the loads that you have is not deleted. It just is that the software is not designed to show all the load at the same time. You can only show live, show dead, show one load pattern. So we have all the loads, we have everything. We are ready to run the analysis, right? We have the geometry, we have everything. What we did right now have something wrong, and I kept it wrong just to teach you something. But let's run the analysis and see how is the analysis look like, okay? So to run the analysis, first I need to make save so that we don't lose the analysis. I'm gonna name it Truss 2. And if you want to run your problem, you can come here and click on this one, run analysis, or you go to analyze and then you come here and run analysis, or you hit F5. So there's different ways. So when you run the analysis, it asks you, do you want to run all the cases, all the load cases that you have, the dead and live, or you want to run only one case? I want to run all the cases. There's one case is called nodal. Nodal analysis is some type of analysis that we need when we do seismic analysis. We don't need it right now. So if you want to escape it, it just shows you what is the degrees of freedom of the structure. How is the structure is going to shape? Like if you have, for example, a structure like this structure has a mode of motion like this, or a mode of motion that it makes this shape or this shape. So it shows you all the possible shapes that your structure is going to make. And we don't do model analysis right now. So if you want to escape this analysis, you can say, don't run this analysis. Don't run this case. So when I click on it, so I'm going to run only dead and live, and I'm going to say, run now. It's supposed to take a minute or a few seconds. It says analysis is done. Okay, so this is the deformed shape of the structure after we run the analysis. And when we start the animation looks normal, right? If you have a dead load, this is roller, the roller is moving, everything looks good, right? Let's see how the live load is going to do to our structure. So if you want to show the analysis from the analysis result from the live load, you go to display and show deformed shape, because we want to see deformed shape. And right now we are going to switch from dead to live, and I'm going to say okay. And also that this one makes sense. You have the live load is pushing, and this pushes this way, because this is how the structure is going. Actually, this is not a real deformation, but the SAP2000 make it much bigger, so that you can feel it. Okay, I mean, like, this is not how the structure is gonna perform in the real life, but the SAP2000 just make it this way so that you can visualize it. And actually, you can make it bigger. If you want to scale the motion, you can go to display, show deformed shape. So the deformed shape control option scaling. So I believe you can make automatic scaling, or you can make user-defined scaling. You multiply the displacement, you can increase it by 10. Let's say okay, and see what happens. Can you see your structure? It doesn't have like a realistic one. Can you see? It's a very big. But if we go back to display deformed shape, let's let SAP2000 handle this, because it make it reasonable. Something like this. All right, so what if we want to do some load combination? You can actually, while running your structure, you can go to define load combinations. And you go to load combination. Actually, that's how we design a structure. We don't design a structure for a specific load pattern, dead or live. We design like a combination of load, like part of the dead, part of the live. So if you guys remember last time we wrote some load combinations. Yeah, so let's make combination number 1. I'm gonna add the dead load multiplied by 1.4. This is one combination. And another combination, and in the same combination, like combo 1. Let's make it actually 1.2. Modify, and the live load multiplied by 1.6. This is this is one of the combinations that we have from last time. We have the dead load multiplied by 1.2 and the live load multiplied by 1.6. And this is only one combination, and this is linear addition. So like add them as it is. Okay, and then I'm gonna say okay. If you want to add all the 7 combinations, so once you hit okay, you add new combination, and you make the dead load multiplied by 1.4, and then you will say okay. So you add all the 7 combinations that we have from last time. And if you want to show the analysis result from a combination, you go to display, show deformed shape, and it asks you dead live, and right now we have other cases. Combination number 1, combination number 2, and if you add more combination, you can add as much as you can. So let's say combination number 1. Okay. Look at the deformed shape. Right now, it has some lateral, but it's not as much as the vertical, so you cannot see them. But this is how it looks like. But let's see what we have wrong in this structure and how can we know it. For trusses, it only takes tension compression, right? So if this truss has bending moment and has shear force diagram values, that means there's something wrong, right? So let's see. I'm gonna go to display results, and I'm gonna show forces on this truss. If you want to show reactions, you can go to joints. You can get from the dead and apply. Okay. You'll find that the structure calculated the reaction 6.95, 6.95, because it's symmetric. But we don't have X reaction Y. Or we have a live load of 5 ton this way. But why we don't have X reaction? Because this only shows the reaction from the dead load. Okay. So if we show the reaction from the live load, I go to display, show reactions from the live load, hit apply. Right now, this is only the reaction from the live load, and that makes sense. I have 5 here, and this 5 with 5 is making moment this way, and these 2 reaction is a counter moment. Okay. If you want to show from a combination, so I'm gonna go to display, show forces, and you can right now make combination 1, and then I will say okay. So you will have X, you will have Y. So all right. So why do I have X reaction is 8? However, I only have live load is 5. Because I multiplied by 1.6, so it got increased. Okay, the second thing, let's display the forces on the frames itself. So when I go to the frames, if you want to show from the dead load, if you want to show the axial force, like the tension compression, you hit axial and then apply. Okay. This is how it looks like, and that makes sense. Like the lower member is under tension, which is blue. The upper member is under compression, which is red. That makes sense. Let's display moment 3-3. Okay, so let me teach you this. If this is the cross section of the truss, this is how the axis look like. So the axis that's coming out of the plane is number 1. This is number 2. This is number 3. So if I want to show the bending moment on this cross section, so the moment about any axis, about 3, right? Because the bending moment should be this way. Okay. If I want to show the shear on this cross section, so the shear is in which direction? 2, this way. So if you want to show the bending moment on this cross section, you hit moment 3-3, the moment about axis 3. And then I will say apply, okay. Here's the magic. So all the cross section of the truss has bending moment. Like the truss acted not like a truss, it's like a frame. So all the joints has bending moment. So that means there is something wrong. What is this wrong? Is that we need to make the moment at each one of these joints is 0. Like I didn't tell the SAP that these joints is a truss joint, not a frame joint. So we'll have to do this by ourselves. So how we can do this? First, I need to unlock my model because I'm gonna redo the analysis. So I'm gonna unlock my model. And then I'm gonna click on all the joints in my structure here. And I'm gonna go to assign joint frame. And in frame, you will find something is called partial release and partial fixity. So what I'm gonna do here, I'm gonna tell SAP2000 that all the frames at the start and end point has moment is equal to 0. It doesn't take any moment. It's a truss member. So we make something called release the moment at this frame. So it can be as a truss. Okay, so I'm gonna make it the moment 3-3 is equal to 0. So it asks you, is the moment is equal to 0 or not? So maybe you can actually decrease the moment to be 0.5. If you have like, this is some cases, if you have a frame and this frame, this joint has some cracking, you make this joint efficiency is not 100%. You make it 0.5 or you make it 0.2, depends on the fixity between the joints. But I know for sure in the trusses that there is no moment. All the moment is equal to 0. So I make the partial fixity equal to 0. So let's see what will happen. It will show you something like this, but there's something here. Why this joint? So it just tell you that there's an intermediate hinge at this joint and at this joint and this joint. But look at this one, this one, this one, this one. They don't have intermediate hinge. Why? Because when we draw them as a one line. We need to divide them at the grids. So this one thing that we need also to do. So I'm gonna mark all these members and I'm gonna go to edit. And then you will edit lines and you will go to divide frames. And in divide frames, you will find something called divide at the intersection with selected joints, frame members. You can do this. There's one with the grids. divide at the intersection with a coordinate plate with visible grids. So you can do it with the grids, or you can do it with the frame member itself, because I know that there's a frame member is intersecting at these joints. So let's say okay. So if I click on this member, you will find it's one piece. So I can do it one more time. And I go back to assign, frame, release, and make it 0 and say okay. So once I do it, all the members have 0 moment at the start and the end. Now I can run the analysis one more time. And I will say run now. So right now I'm showing moment M33 and the moment is equal to 0. So here is moment 33. There is no moment. So all the moments are equal to 0. Let's do something else. I'm gonna unlock my model and go back to define and change the load pattern. And I'm gonna change the dead load from 0 to 1. So what I'm gonna do here, modify. So what do you think is gonna happen when I run this analysis, changing the load pattern, dead load from 0 to 1? What do you think is gonna happen? It's gonna calculate the dead load, store it in the dead load combination, and how's the bending moment is gonna show here? Moment here is 0, moment here is 0, and there's a distributed load of the dead load in this member. How is the bending moment of this member is gonna look like? Like a parabolic WM is 4/8 for each member. So let's see it. Run now. So this is how it looked like. Can you see? There is a bending moment of this truss because we included the dead load of the truss itself. So there is parabolic curve for each truss, but this is not our case. So the right one is that I have to unlock my structure. And then I'm gonna define load pattern. If you have a bending moment on your truss, so this is not truss. Modify. Okay. And then I'm gonna run my model. Done. Okay, if you want to show right now, display the forces on the frames, and you want to show right now the axial force. Let me make this XZ. So this is actually how we solve a truss. Usually solving this truss, it only takes like 5 to 7 minutes, but we spent like more than an hour to do it because we were like navigating each one of these panels: define, draw, assign, display. Okay. So these actually most of the things that we are going to use in this class. Assign, what we use define, right? And then we use assign, display, and analyze. We choose it from here. And also we did edit when we divided at the joints. Okay. Right now the lecture is recorded. You can go watch it from home. I'm gonna put a SAP homework so that you can start with. I'm gonna give you some trusses to solve. And next time we are gonna solve the frames. Okay. So I believe we right now we have a good introduction for SAP2000 you can start with. And next time we are gonna do frames, and the one after we are gonna do slabs, so that we can build a good base so that we can start ETABS. Okay. All right. So if you guys have any question about the midterm exam, you can stop by my office, and I'm happy to help you.
The license on the program is an instruction